Good day. Nhasi toda kudzidza pamusoro paIsaac Newton. We want to discuss the Newton laws of motion. So our first note is going to be a quote from Isaac Newton himself. Sir Isaac Newton is quoted to have said, "If I have seen further, it is by standing on the shoulders of giants." So this is one of the most famous quotes by Sir Isaac Newton. If I have seen further, it is by standing on the shoulders of giants. Saka, the moral of this quote, Isaac Newton was just trying to tell us that science is a collaborative, kana kuti a collective effort. In order for Sir Isaac Newton to be able to propose the Newton laws of motion, he was leaning on science which was discovered by other people before him. And the giants which Sir Isaac Newton refer to persons like Galileo, Galilei, persons like Copernicus, persons like Aristotle, Greek philosophers, etc. Saka, what we derive from this quote is, kana tichida kuva successful, especially in the pursuit of science, we should know that science is done well if it is done by a collective. So that is what we learn from this quote. It's one of my favorite quotes. Let us now go over to the first law. So we have 3 Newton laws of motion. Mitemo inogavhena motion. Kana titi motion tikutaura pamusoro movement from a point to another point. So the first law inoti iyo, all objects remain stationary or continue to move with constant acceleration unless an external force acts on them. All objects remain stationary or continue to move with constant acceleration unless an external force acts on them. So, pamalaws aya, what I advise is, practice in such a way kuti you will be able to almost quote them word for word. Saka handisi ku-encourage rote memorization yekurangarira kuti first law inotaurwa sei, or cram that sentence and then you reproduce kana wabvunza about the first law of motion, but rather kubata ma-keywords within the definition. So we are talking about all objects, but what happens to these objects? These objects, what happens to them? They remain stationary. Saka nachitaura pamusoro pekuva stationary, of course kutaura pamusoro pekumira, handiti chinhu chisiri kufamba. Saka all objects remain stationary, or they do what? They move with constant acceleration. They move with constant acceleration unless what? An external force acts on them. Saka ndoma words akakosha. We are talking about objects, dzimwe nguva amwe mabhuku anoti bodies, then they are remaining stationary or moving with constant acceleration unless what? Unless an external force acts on them. But before we go any further, we should appreciate kuti Isaac Newton proposed the 3 laws of motion in his book Principia. So we want to discuss how Sir Isaac Newton put it in Philosophia Naturalis Principia Mathematica. Saka in short, book iri rinongonzi Principia, the most famous book in physics, Principia. But in full rinonzi Philosophia Naturalis Principia Mathematica. Kana tika transliterate, kana to translate this Latin into English, zvinenge zvichireva kuti mathematical principles of natural philosophy. And I'm taking this from a translation by Andrew Mott. Saka we need to appreciate what Sir Isaac Newton, ivo mbune pavakanyora this first law, vakainyora sei. So Isaac Newton, the way he writes this law, vanoti ivo, every body perseveres in its state of rest or of uniform motion in a right line unless it is compelled to change that state by forces impressed thereon. Saka everybody, kuti everybody ndipo isusu patangachiti chi every object. Then kuti perseveres ndiko kuti chi remains in its state of rest. Iyi ndo inonzi chi stationary state kana kuti remains stationary or of uniform motion in a right line. Ndo yatati isusu constant acceleration. So it's constant acceleration in a straight line. Saka kuti right line, so about straight line, unless it is compelled to change. Saka compelled to change ndiko chi acted upon. Compelled to change that state by forces impressed on them. Saka forces impressed thereon ndiyo chi external forces. So zvataita ndezvekuti tangotora this Victorian English tikaita breakdown and simplify. Let us give an explanation of this law. In our explanation, I want you to imagine something. Let us say we have an object. This is the object. Anditka. Saka, this is object in case 1. The object here in case 1. Then we also have an object in case number 2. In case number 2, difference responding to this object is now moving in a straight line. Saka it's moving in a straight line with a constant acceleration. Saka acceleration kada kuitaura murimi rwamai ngatingoti haisi kuchinja speed. Handika riri kumove in a straight line with the same speed. Haisi kuchinja speed. So iri object yakangomira, then object iri kumove. So what the law says this body and object remains in its state of rest. Saka iri in what? It's in a state of rest. Inoramba iri in this state of rest. Andika kana kuti an object remains in this state of motion. This is now a state of motion with constant acceleration. Don't worry, acceleration should define a later. Zvakanaka usunonga tingoitora ise speed with constant acceleration in a straight line. And in a straight line tasina kutaura hedu zvakakosha. Saka a body remains in its state of rest kana kuti its state of motion with constant acceleration in a straight line unless an external force. Saka kunoku kune inonzi external force acts upon it. Saka nachitaura pamusoro pe-external force tiri kureva kuti tikaenda pacase 1 ukachipusha chiuyu ichi with a certain force togona uchipusha then new position yacho inenge iri ino ichi handiti. Saka tachipusha kubva panapa kuya panapa. Eno panga tisina kuchipusha, tisina kuapply ichi, tisina kuapply an external force, this body kana this object yaingoramba iri in its state of rest. Eno tisina kuapply external force, that body yairamba iri in its state of rest. Understand? Okay, then ino body iyi manje iri kumove in a straight line with a constant acceleration. Tinogona kusvika toapply external force panapa. Mapaona? Then external force ikabalance ne this force yobva yamira. Saka deno tatisina kuapply external force, object yedu yairamba iri in a state of motion in a straight line with a constant acceleration. Saka zvirongotaura size Newton ndezvekuti tikatora kana kuti pen tikaisa patable pakashayikwa force inoibata, handitika tikaenda somewhere tikadzoka after 10 years tinofanirwa kuwana peni iyoyo iri patable at the exact location yatakaisiya. Saka it is an object remaining in its stationary state kana kuti an object remaining in its state of rest. Another case ndeyekuti kana paine kana kuti ngatiti we have a moving body kana kuti ngatiti mota haizi kuchinja speed iri kungoramba ichimuvha at 10 kilometers per hour in a straight line, inoramba iri in that state of motion kana pasina an external body yaita act about it kana kuti impressed on. So this is Isaac Newton's first law of motion. I hope I sufficiently explained it. Saka, what you need to do is to look at this retake. So kana takuda kuziva tikavunzwa kuti what is the first law of Newton, your answer should be a body maintains its state of rest. So this is a body, it maintains its state of rest or of uniform motion in a straight line unless an external force acts upon it. I think this retake makes it simpler. A body maintains its state of rest or uniform motion in a straight line unless an external force acts upon it. Okay, we now need to go to the second law of motion according to Sir Isaac Newton. Isaac Newton's second law of motion. A force acting on an object will produce an acceleration that is directly proportional to the force, and the object will move in the same direction as the force. So when it comes to Newton's second law of motion, I do not encourage you to quote it using this word definition. There's a simpler way. You know, the way of science is to find the simplest way of expressing complex phenomena. Saka, when we are quoting the second law of motion, we are not going to be using this word definition. We are going to use a mathematical definition. Saka definition E ndiyo inoita derive into a mathematical equation which we are going to be using. So let me just reiterate it, then go over to the mathematical definition. A force acting on an object will produce an acceleration. And Saka, if we have an object, this is the object, and that it was in a state of rest. Ingori object, iripa flat surface. So then we have a force panel, and we push with a certain force. Saka, a force acting on an object will produce an acceleration. The moment yatinotanga kuipusha force ino inability to produce an acceleration, so yanotanga kumove in this direction, and so it produces an acceleration that is directly proportional. So this acceleration produced is directly proportional to the force. So the force is directly proportional to the acceleration, and the object will move in the same direction as the force. Saka kana tine body tikatanga kuipusha aro iruratidza direction of force, andika body inotanga kumova in the same direction as the force. Force yedu iriku yakatarisa kunoku, body yedu iri kumuvha ichienda uku. I think that makes practical sense. What is special here is this statement. This force is directly proportional to the acceleration of the body. Force iri kuapplywa iri directly proportional to the acceleration of the body. Direct proportionality tichaidzidza patichaita proportion in mathematics, but what you should know is direct proportion inongoreva kuti if we increase the force, the acceleration will also increase. If we decrease the force, the acceleration will also decrease. It makes sense. Tiri kupusha chinhu chacho chiri kumove in the direction of the force. Kana tikawedzera force yedu, acceleration, kumhanya kwechinhu ikoko kunofanirwa kuwedzera. Tikaredusawo force, kunofanirwa kudi kuredusa. To the extent yekuti kana tikatanga kuapply zero force, chinofanirwa kutorega kumuvha zvachose. So this is the second law of motion. Let us go to the mathematical definition. In our mathematical definition, tichatangira pa this statement, the force is directly proportional to acceleration. All right. Saka, when the force is directly proportional to acceleration, remember, if we are talking about a body, zvoreva izvo kuti where m is a constant, the constant here is mass. And tichaita proportion, tichadzidza pamusoro pe-constant. Saka mass ndo inenge iri constant. Saka tikada kureplace this proportion sign, inenge yakuti f is equal to, toisa constant yedu, totaisa a yangagara aripo. And saka this is the mathematical definition of the second law of motion. F is equals to ma. But remember zvatakataura, where f is force and m is mass, a is acceleration. You see, that would define Newton's second law of motion. So I think this is easier. So what is Newton's second law of motion? F is equals to ma, where f is force, m is mass, and a is acceleration. Let us see how Sir Isaac Newton put it in his Principia. In Principia, Sir Isaac Newton said the alteration of motion is ever proportional to the motive force impressed and is made in the direction of the right line in which that force is impressed. This complicates the science so much. But let us break it down. Remember, tiri kukota Principia out of interest. Hatisi kuti kremai wedding iri muprincipia. No. Tiri kungokota Principia out of interest. So the alteration of motion, kana chiti alteration tikutaura pamusoro pe-change. So the change of motion, handiti iyo change of motion ndochi acceleration. So the acceleration is ever, not always, not ever kuti always, proportional to the motive force. Motive force, this is the force causing motion. Iforce iri kuita kuti body yacho imove kana kuti object imove. So this is the motive force impressed. Wedra kuti impressed varishandisa to mean applied. And is made in the direction of the right line in which that force is impressed. Saka iyi statement inongoreva kuti direction of force. Saka pa explanation tinongodzokorodza zvatanga tichitaura. We have an object, we apply a motive force panapa, this body begins to move in the direction of the force, and the acceleration, cannot change in motion of the body, is going to be directly proportional to the force. But chisiri kuchinja panapa ndozvorati constant, its mass, where the constant is mass. You understand? So ndozvirongotaura, there is not much here. Then of course, we from here, from f directly proportional to a, it becomes f is equals to ma. We have defined the second Newton law of motion. The second Newton law of motion. Done. So let us work through this example. A car of mass 500 kgs travels at an acceleration of 5 meters per second squared. Find the force exhibited by the engine. Saka kuti tiweke panapa tichangoti F is equal to MA. Then question iri kuda titsvage the force. Saka tiri kutsvaga F. What is M? M ndi 500. Andika. Then trick iripo ndekuti kana zvakanyorwa in SI units. Maybe let us do this. Remember patakaita our first topic tichidiscuss physical quantities. Takati isusu 1 kg meters per second squared is equal to 1 Newton. And kana kuti inogona kunyorwa yakadai so 1 kg meter second the negative 2 is equal to 1 Newton. And it derive from this relationship F is equal to MA. Tichidefine a Newton. Mapaona. Saka kana masi yedu yakapiwa in its SI unit. Kureva kuti in kgs multiplying acceleration yedu kunyange iri a derived physical quantity but yakaderive yo from my base physical quantities. Kureva kuti kana iri meters per second squared, meters iriyo SI unit ye length, seconds iriyo SI unit ye time. Saka it's times 5 meters per second squared. Answer yedu chatongenyora in newtons. And kashoma kuti vaunze zvisina kudai so because they are not out there to hunt you. You understand? Kashoma kuti vaunze zvisina kudai so. So F is equals to MA. Okay, so this is equal to 500 times 5 ndiani? Ndi 2500. 2500. Saka panapa answer yedu inge iri 2500 newtons. Yatopera. Saka to apply the second Newton law of motion, F is equals to MA. Tikawana answer yedu 2500 or 2500 newtons. Chandanga explain panapa ndechekuti kana mass yedu iri in kgs, then acceleration yedu iri in meters per second squared, our answer is going to be in newtons. And remember, the Newton is the standard international unit of force. We did that to honor the work of Sir Isaac Newton, especially in his Principia. We are now taking you to the third law of motion. Isaac Newton's third law of motion. If body A exerts a force, before we go anywhere, this is my favorite of the three. So maybe you might give extra attention here. If body A exerts a force on body B, then body B will exert an equal but opposite force on body A. If body A exerts a force on body B, so we have two bodies. Maybe Charles will start explanation panel. They're exerting a force on each other. Body A exerts, cannot applies, cannot impresses a force on body B. Then body B will exert an equal but opposite force on body A. This law speaks to what is called the balance of forces. Saka, you can imply it, you can define the third law in that way, or rather you can simply put it like unongoti, for every action there is an equal opposite reaction. For every action there is an equal but opposite reaction. So let us see how Sir Isaac Newton puts it in Principia. To every action there is always opposed an equal reaction. Victorian English, you know that is. To every action there is always opposed an equal reaction. Or the mutual actions of two bodies upon each other are always equal and directed to contrary parts. Saka indo kaka explanation kakakoshera nawe kuti directed to contrary parts. Let us explain this law. We have body A iri pamusoro pe body B. Saka body A iri pamusoro pe body B. Zviri kutaura panapa ndezvekuti body A iri kuexerta a force on body B. Force iyi ndiani? Ndi FA. Handiti body A iri kuexerta a force FA on body B. Body B ichaexerta an equal but opposite force FB on body A. Saka FA, force iri kubva kubody A, iri equal to FB, force iri kubva body B. Asi zviri kuitika ndezvekuti maforces aya they are in opposite direction, anenge akatarisana. So there is a balance of forces. Take it for example, pane chair panapa. Anditi, then iwe wouya wogara pachair inoi. Andika, iwewo pausvika uchigara waexerta a certain force FG and force yaexertwa naGeorge. Chair iyi inofanirwa kuexerta an equal but opposite force FT kuitira kuti kubalansa kwemaforces kuite kuti chair isatsemuka handika kana kuti iwewe usapandwa kure kune chair yacho. Saka maforces they exist, they balance. We are talking about the balance of forces. You understand? Kana kuti forces are in a state of equilibrium. Kana chiti equilibrium tikureva kuti maforces they are balancing off. They balance off. Counting the balance sheet, the balancing off of forces. So let us go back to the definition. This is the definition I want you to use. If body A exerts a force on body B, then body B will exert an equal but opposite force on body A. For every action, there is an equal but opposite reaction. So this can apply in everyday life, of course. Ukanditsunya chakutsunyawo. This is revenge philosophy. For every action, there is an opposite equal reaction. Of course, in human relations, we can conclude that for every action there is a reaction, but it's not always the case that it's an opposite but equal. Sometimes it's not equal. It's not equal in terms of the reaction is not equal to the action. Saka ndonawo iri apa hama dzangu. I think the third law is equally obvious and equally understandable. From this point, we have an exercise. I want you to write this exercise. Number 1, state the 3 laws of Newton. Then number 2, why does suddenly applying emergency brakes in a car causes the passengers to be jerked forward? Saka iya ndina kuexplaina, but in your explanation, I want to give you a hint. And hint iri panapa ndeyekuti first law of motion. Saka in your explanation, you have to use Newton's first law. I don't know how we are going to use it. Maybe we are going to research it. I don't know. But hint ndeyekuti number 2, when answering it, you are going to use the first Newton law of motion. Then number 3, 1000 newtons of force are used to pull a 250 kg object. With what acceleration is the object going to move? Panapa, if I'm generous, hint ndeyekuti pachashanda the second law panapa. Then define acceleration. Panapa, I want you to use the second law. So I want you to define acceleration using Newton's second law. So this is a very short exercise, just 10 marks. You write it and we mark it. Otherwise, thank you. If you need help in physics, chemistry, biology, combined science, ZIMSEC, or any other syllabus ordinary level, and some subjects for advanced level, especially pure mathematics, you can contact me on this number. It's a WhatsApp number, +263 71 046 9150. So if you are in Zimbabwe, you can just write it as 071 046 9150. Otherwise, thank you for your attendance and take care.